Yeah, degree to curve in the air. 3 forms, 1 function, all connected there. Standard, factor, vertex, triad, we ride. Shift between the forms like a smooth moon slide. Standard form, write it clean. Y equals ax squared plus bx plus c. Classic scene. Domains all real numbers, that's the start. C is the y-intercept, 0 c on the chart. If the absolute value of a is greater than 1, it's skinny, tight, and steep. If the absolute value of a is between 0 and 1, it's wide. It spreads out deep. Positive a means a minimum at the vertex turn. Negative a means a maximum. Watch it burn. And that same a stays the same no matter what form you see. Standard, vertex, factored, a is the key. Axis of symmetry, find it this way. X equals negative b over 2a. The x done is h, lock it in the rule. Plug h in the equation to get k. Yeah, you're playing it cool. Yeah, you're playing it cool. Or complete the square, another way to switch. Standard into vertex without a hitch. Vertex form coming in, now swap the view. Y equals a times parenthesis x minus h parenthesis square plus k. That's true. H is the vertex x, k is the vertex y. That order pairs the turn when the curve goes by. K sets the range, watch the graph obey. Positive a means y is greater than or equal to k. Negative a flips it, heads the other way. Y less than or equal to k. Let the vertex lead the play. Expand factored, expand vertex standard, we return back to ax squared plus bx plus c. Same curve, same turn. Quadratic triad, 3 ways, 1 name, same parabola, just a different frame. Real roots are x-intercepts. For y equals 0, show those x values of p and q. The roots we need to know, then write it factored once you know p and q. Y equals a times quantity x minus p times quantity x minus q. That's what roots do. Standard to factor, set y equal to 0. Factor or use the quadratic formula, the roots will show. Vertex to factor, set y equal to 0. To solve for x to find the roots, that gives you p and q. And if you already got p and q on the page, the midpoint gives h, the x value of the vertex on stage. H equals p plus q all over 2, center of the span. Then find k by plugging h in like a plan. Same a in every form, never changing lanes. That's how the triad stays linked in chain. Quadratic triad, standard, vertex, factor 2. Move between the forms with what you know to do. From standard to vertex, use negative b over 2a for a. From factor to vertex, p plus q over 2 gives a. Set y equals 0 for roots, that's the intercept track. Same a every time, so you can always trace it back. Expand it out, factored or vertex, watch the terms return. Ax squared plus bx plus c. Same graph, same turn. Skinnier y, max or min. Domain all real, let the curve begin. 3 forms, 1 function, triad complete. Quadratic on lock with the steady beat.